Hello everyone, welcome to the Academics. I'm Amrita. I firmly believe that you should keep trying until we get it right. So in our previous videos, we have discussed about direct variation and also some questions from direct variation. In our last video, we did discuss about inverse variation and some basic questions on inverse variation also we solved. Now let's solve some more questions where it will require a little more mind to be used to solve these questions. So if you are watching my videos and liking them, then please like, share and subscribe to my channel Siddhi Academics to stay updated with whatever I am posting. Let's start. So this question says 8 men can dig a field in 14 days, working 6 hours a day. In how many days can 7 men dig the same field, working 8 hours a day? Now you see, we clearly know that when there is an increase in the number of men, the number of days required decreases, and vice versa. So this is a question of inverse proportion, there is no doubt about it. But how do we go about solving? Here every parameter is changing. Men is changing, the number of hours they work in the field is changing. How do we go about it? So what we can do is we will find units of it, right? How much time will be required or days will be required for 8 men to dig the same field if they are working not 6 hours but 1 hour in a day. Let's find out that. From there, let's take it like if one man works for 1 hour a day, then how many number of days will he require, right? First, we try to divide and take it into one man, 1 hour a day, how much number of days it requires to dig the field. Then we will build on it. Then we will see that how much time 7 men will require to complete the same work, I mean digging the field, if they are working for 1 hour a day. Then again from there again we will build on it. We'll try to find out 7 men working for 8 hours, not 1 hour now, 8 hours. How much number of days will they require to dig the same field? So this way we can just first divide and then build on it to reach our final answer. So what is the given thing we have written here? 8 men working 6 hours a day dig the field in 14 days. So 8 men, which implies that 8 men, if they work for 1 hour a day digging the field, how much time will they require? Definitely they will require more number of days because they are reducing the amount of work in a single day. So number of days will definitely increase. There is no doubt about it. So 6 into 14, 6 times more number of days will be required because now they are only working for 1 hour a day, right? So 6 into 14 if we do, that will be 84. So 84 days will be required for 8 men if they are working 1 hour a day to dig the complete field. Now that's for 8 men. Now what about one man? If one man works 8 hours a day, then how much time he will take to dig the field? Will it take less? No, obviously not. He has to do the job of 8 people, right? So 84 into 8 will be how the amount of effort that one man needs to put. So that will go towards the number of days, right? So 84 into 8, he is doing, one man working 1 hour a day is trying to do the same work which 8 men were doing in 1 hour a day. So definitely he will take a lot more number of days multiplied by 8. He is doing 8 people's job. So into 8. So 8 4s are 32, 3 gets carried over, 8 8s are 64, 64 plus 3 is 67. So number of days now increases, it becomes 672. Now what happens if 7 men working 1 hour a day dig the field? We found how much time, 672 days will be required by one man if he is working 1 hour a day to dig the field, complete field. Now the same field if is going to be dug up by 7 men working 1 hour a day, how much time will he require? 672 divided by 7, because now the number of days required will be less because more hands have joined on to the same work. So now we have to divide. Definitely the number of days will lessen now, obviously, because more hands have joined to do the same work. So let's divide. 7 1s are 7, 7 8s are 7 9s are 63, 7 9s are 63. So 67 minus 63 is 4, so it becomes 42. Next step, So 7 6 are 42. So they 7 men working 1 hour a day will dig the field in 96 days. Now what happens? We are reaching to the final leg of the question. What happens if 7 men working 8 hours a day dig the field? Now if they are same 7 men are working for not 1 hour but 8 hours a day, definitely now the number of days will further lessen. By how much? By 8, because they are working 8 hours per day. So now if I divide, what will become? 8 ones are 8, and here also 8 ones are 8, 9 minus 8 is 1, so it becomes 16 in the next step. So it becomes 8 twos are 16, so 12 days. 12 days is the answer. So 7 men working 8 hours a day, 7 men who are working 8 hours a day require 12 days to come to dig the entire field. So this is how we reach the answer for this kind of question. So please don't get worried if every parameter is changing. You first bring it down to 1%, 1 hour, and then build on. Take the whatever the question is asking, how many number of men in 1 hour can complete the work. Then if the question is saying like here, it's saying 7 men in 8 hours. Now 1 hour you have found 7 men in 1 hour. The next step you find out 7 men in 8 hours. If they are working 8 hours a day, so how many days will they require to complete the work? So this way you can solve bit by bit and reach the answer without panicking. Okay, let's do this question. A contractor undertakes to build a wall 1000 meter long in 50 days, and for that he employs 56 men, but at the end of 27 days he finds that only 448 meter of wall is built. That means he could gauge that after for the remaining days, uh, in the remaining days this wall of 1000 meter long will not get completed. He could gauge that. So what does he want to find out? How many extra men must the contractor employ so that the wall is completed in time? So 1000 meter long wall, out of that 448 has already been built. So 1000 minus 448 is 552. So 552 meter of wall is to be built. And how many number of days are left? Out of the 50 days, 27 days are already over. So 50 minus 27 is 23 days. So we need to find out how many more men will be required to build 552 meter of wall in 23 days. This 56 men are not enough. So let's try to find out. 56 men build a wall 448 meter long in 27 days, right? This is what the information is given to us. Now let's try to find out, let's break it down. Break it down by bringing everything down to one unit. So let's understand how many men will be required to build 448 meter long wall in one day. Okay, because we are ultimately going to calculate for 23 days. So how can I find for 23 days if I do not understand in one day how many men will be required to build the wall 448 meter long? So how can I find that? 56 into 27, that is 56 into 27 I do, then only I can find out the number of men required to find out build wall of 448 meter long, because the number of men will definitely be a lot more in one day. That much same amount of work, it has to be done by definitely 27 more times men. So 56 into 27 I need to do, 7 6 are 42, 4 gets added over, 7 5 is 35, 35 plus 4 is 392, then this will become 112. 56 into 2 I am talking about that. Now if you add this up, 2 comes here, 11, 1 gets carried over, 5, 1512 men will be required to build wall 448 meter long in one day. So now what we can do is we will try to find out how many men. Again, this also will break it down, because ultimately we are trying to find out the remaining wall, that is 552 meter long wall, how many men will be required. So this also will break down, will bring this wall length to 1 meter. How many men will be required to build wall 1 meter long in one day? So 1512 divided by 448 will give us the number of men required to build a wall 1 meter long. Now, how many men build a wall Now what? We will now build on again. We are trying to find out now in one day how many men will be required to build wall of 500 meter, 552 meter long. Okay. Right now where we have found that 1512 divided by 448 will be the men required to build 1 meter wall in one day. So now from here we need to build on. We will try to reach the answer. We are now understanding how many men will be required to build a wall which is 552 meter long in one day. So definitely number of men will increase here, right? Because the length of wall increased. So definitely how many times it has increased? By 552 times. So here I need to multiply, I need to into 552. So 1512 by 4848 were the number of men who were required to build wall 1 meter long in one day. Now this into 552 to this particular value gives us the number of men required to build the wall 552 meter long in one day. Now, how many men, we are reaching the final step, how many more men, so not how many more men, how total number of men required to build a wall 552 meter long in 23 days. So, in one day, these many men will be required for in 23 days. Definitely less number of men can do, because work will be spread over number of days. It's not one day work, it is now 23 days work. So work will be spread over a whole number of days. So how do I find for 23 days? Here we need to divide. This is what inverse proportion is all about. So 1512 divided by 448 into 552 divided by 223. This whole divided, whatever the numerator, the whole divided by 23 gives us the final number. I mean, finally we get the total number of men required. So let's see. Let's try to cancel out. 23 ones are 23. So here 23 twos are 46. So 56 minus 46 is how much? That is 9. So 92. 92 means 23 into 4 is 92. So 24 comes here. Now let's divide here. 4 ones are 4, 4 ones are 4, 4 twos are 8, 4 6 are 24, 6 ones are 6, then 5. Okay. Then where what we can divide? Yeah, 2 threes are 6, 2 fives are 10, 2 6 are 12. Now let's divide again further. So 7 eights are 56, 7 twos are 14, 15 minus 4 is 1. So it becomes 11 here. So 7 ones are 7, 7 6 are 42. So this is 216, right? So is it divisible by 8? 8 to 16, yes it is. So 8 ones are 8, it becomes 8 twos are 16, 21 minus 16 is 5, it becomes 56, which is 8 sevens are 56. So 27 into 3 is left. 27 into 3, 81 men will be required to complete the entire work. So how many extra men will be required to, should the contractor employ? How do I get it? 81 minus the number of men already employed, that is 56. 81 minus 56 is how much? That is 11 minus 6 is 5, and 7 minus 5 is 2. So 25 more men will be required. 25 more men will be required for the 552 meter long wall to be completed in 23 days. All right. Let's do this question. This is a different kind of question again with different many parameters involved. So here also we need to break down into one unit and then go on to build on the question to find out exactly what the question is asking us. So let's read this question. 10 men working for 6 days of 10 hours each. That means each day of the 6 days they are only working for 10 hours. That means not the entire day. So 6 into 10, 60 hours is what they have um, been able to work in those 6 days. So 10 men working for 60 hours finish 5 by 21 of a piece of work. How many men working at the same rate? They are not going to increase the number of hours in one day, same rate, and for the same number of hours each day will be required to complete the remaining work in 8 days. Remaining work is how much, that we have to find out, and 8 days means how many working hours that will translate into, that also we need to understand. So they are going to not work more than 10 hours. So 8 into 10, they have got 80 hours of 80 hours time to complete the remaining work. Now how much is the remaining work? If the entire piece of work I take is 1, right? Out of that fraction, out of that whole number 1, they have been able to complete 5 by 21 fraction of the work. So how much fraction of the work is left? So I can easily find out by doing 1 minus 5 by 21. So how much will be 1 minus 5 by 21? That will be 16 by 21 is the remaining work. Remaining work is 16 by 21 of the work is left to be done. So that we need to find out how many men will be able to complete in 80 hours. So let's move towards solution. 10 men work for 60 hours for 5 by 21 of a work. Means they are able to complete 5 by 21 of a work in 60 hours. Where did the 60 hours come? 6 days, 10 hours each. So 6 into 10, 60 hours. Now we have to go down to 1 unit. We have to break the question down. That's what we discussed. So let's try to understand how many men will be required to complete the same work, that is 5 by 21 of the work in 1 hour. Definitely a more number of people will be required to complete the same 5 by 21 of the work in 1 hour. So how many more? That's definitely 60 times more will be required. So 10 men into 60 will give us 600 men. 600 men will be required to complete the work, that is 5 by 21 of the work in 1 hour. We have broken down, we have come down to 1 unit of an hour, right? Then we have to again break it down and understand in 1 unit of work. 1 unit of the work means whole work. If I say one work, does it sound good? No. So I have to find out how many men will be required to complete the, I mean, uh, for 1 hour to complete the whole work. In 1 hour, the whole work, how many men will be required to complete? So the number of men that will be required to complete the whole work. Whole work means what? 1 unit of work. Here also I am trying to break down only. That work is how much? 1 unit of work. 1 unit of work, to complete that, how many men will be required to complete in 1 hour? So how can we find that? We have to do 600 divided by 5 by 21, right? Which is ultimately 600 into 21 by 5, right? So this will become 5 ones are 5, 6 minus 5 is 1. So it will become here 10. So 5 2s are 10. 120 into 21. I'll keep this like that. I'm not going to find the product. So this many men will be required to complete the whole work, that 1 unit of work in 1 hour. Now we need to understand these men, these many number of men are okay for this much. But if in 80 hours they have to complete that whole work, that is that 1 unit of work, then definitely less people will be required, right? Because the work will be spread over 80 hours, not in 1 hour. So 120 into 21 divided by 8. Can you see how we are approaching the answer bit by bit? Now this is what will be required. These many number of men will be required to complete the work in 80 hours, the entire work, that is that 1 unit of work. But are we trying to find that? No, we are trying to find in 80 hours the remaining work, how many men will be required. What is the remaining work? 16 by 21. We have already found it here. Remaining work is 16 by 21. So 120 into 21 by 80 men that we found out in this step into 16 by 21 will give me the number of men that will be required to complete the remaining work in 80 hours. So 21 and 21 will get cancelled. Now here if you see, yeah, 16 will, 16 ones are 16 and 16 fives are 80. Done. So now 5 twos are 10. 12 minus 10 is 2. It will become 20 here. This is 20. 5 fours are 20. So what did the answer come up to be? 24 men. 24 men will be required to complete the work in 80 hours. Okay, to complete the remaining work. So we found the answer. This is how we solve this kind of questions bit by bit. First we do for one unit and then we move to the next unit, right? So equal to 24 here also I'll write. I hope I'm clear with this. If you have any doubts, please let me know in the comment section.